All right, welcome back, class. So this will be Unit 7, Section 2A, and this will have to do with ellipses. So an ellipse, as you can see down here, it's kind of more oval shape, and we'll get into why that is in a sec. So we will be able to graph an ellipse centered at the origin. So in all of these examples today, they will be centered at the origin. So again, that's where our HK is 0, 0. And then we will be able to write the equation of an ellipse centered at the origin. So pretty similar with the circles, but it's going to look a little different with the equation. Main thing to note with the vocabulary, the foci, they are 2 points that are equidistant from all points on the ellipse. So that's this point here and this point here. The major axis line connecting the foci. So in this case, the major axis is the x-axis. Vertices, 2 points where the major axis intersects the ellipse. So again, these would be the vertices here, since this is the major axis. And then the minor axis line perpendicular, so that would be the y-axis here. And the co-vertices are 2 points where the minor axis intersects. So these would be your co-vertices. That point here and this point here. So it says A is greater than B will tell you if you have a horizontal or a vertical major axis. And there's a lot going on this page, but once we break it down, it'll make sense. So right here it says ellipse with horizontal major axis will be such that x squared over a squared plus y squared over b squared equals 1. So in this case, where a is greater than b, it lives under the x squared value. So the major axis here, we don't want highlighter. The major axis is the x-axis, and since b is under the y squared, that would be our minor axis, is the y-axis. And then when we look over to this one, now a is greater than b here, and when we square something that's bigger than b, it'll still be bigger than b squared. So now our major axis will be under the y-axis. So the major axis is the y-axis, and now the minor axis is the x-axis. And one thing to note, when we are graphing ellipses, it's always set equal to 1. And then to find the foci, it's of the form a squared minus b squared equals c squared. That's how we can find, like, the in highlighter mode again, that's how we can find the focus. So for example 1, it says graph the ellipse. All of these examples are centered at 0, 0, so the center is right at the origin. And to find which values are a squared or b squared, we need to remember that a squared must be bigger than b squared. So in this case, 49 is bigger than 4. So 49 equals a squared. So when we take the square root of both sides, a equals plus or minus 7. And since it lives under the y-axis, this is our major axis. Whoops. So the vertices then, the vertices are on the major axis, will be 0, negative 7, and 0, positive 7. So we go on the y-axis 7 units up, because that's 0, 7, and then we go 7 units down, that's 0, negative 7. To find b, this is b squared. So when we square root both sides, b equals plus or minus 2. So for our co-vertices, we have negative 2, 0, and 2, 0. So So we go 2 to the left, that's negative 2, 0, and then 2 to the right, that's 2, 0. Now we can draw our ellipse. So that's it right there. To find the foci, it was c squared equals a squared minus b squared. So a squared was 49, b squared was 4, and we are solving for c. So c squared equals 45. When we take the square root of both sides, we get c equals, let's see, plus or minus 3 square roots of 5, which is approximately plus or minus 6.7. And the foci also exist in the major axis. So it'll be 0, negative 3 square roots of 5. That looks terrible. 5 and 0, 3 square roots of 5. So it's plus or minus 0. It's about approximately 6.7. And so that's where our foci will exist. Next, graphing this ellipse. Earlier I mentioned it always, for an ellipse, must be equal to 1. So we're going to divide both sides by 144. So then we get 9 divided by 144 is 16. So then 16 divided by 144 must be 9 equals 1. We're looking for which axis is the major axis, so we're looking for which one is bigger. 16 is bigger than 9, so that's our a squared. Take the square root of both sides. A equals plus or minus 4. So the major axis is the x-axis. So for the vertices, which live in the major axis, we have negative 4, 0, and 4, 0. And all these examples will be centered at 0, 0, the origin. So negative 4, 0, that's 4 units to the left. 4, 0 is 4 units to the right. Then we have our b squared, which equals 9. So equals b squared. I'm going to do it up here. When we take the square root of both sides, we get b equals plus or minus 3. The minor axis, that's where the co-vertices are. This is under the y-axis, so it'll be 0, negative 3, and 0, 3. So we go 3 units up and 3 units down. We have an ellipse here, and then we're trying to solve or find the foci. So again, we have c squared equals b squared, which we found to be 16, minus, or excuse me, 16 was a squared, minus b squared was 9. So we have c squared equals 5. Take the square root of both sides. C equals plus or minus square root of 5, which is approximately, let's see what I found. I can't find it. That's all right. Well, then I can do it over here. Oh, I see. This is plus or minus 7. So if we were in class, somebody could have probably told me. So now I can, that's why that was over there. Somebody probably noticed that. Okay, so that's approximately 2.65. And the foci lives on the major axis, so this is minus, we'll put radical 7, 0, and radical 7, 0. So that's 2.65 units this way and 2.65 units that way. All right. Graphing the ellipse. Again, we want it equal to 1. So we're going to divide both sides by 16. So 16 over 16 is 1. So we have x squared over 1. 4 over 16 is 1 over 4 equals 1. Major axis, the value that's bigger, so this is equal to a squared. Take the square root of both sides. A equals plus or minus 2. These are all centered at 0, 0 in these examples. So the vertices are on the major axis. It lives under the y-axis. So the vertices will be 0, minus 2, and 0, and positive 2. So centered at the origin, 2 units up and 2 units down. This is equal to b squared. So the square root of 1 is plus or minus 1. Co-vertices are on the minor axis. That's under the x-axis. So this is minus 1, 0, and 1, 0. So this ellipse is pretty small. The foci, we have c squared equals a squared, which was 4, minus b squared, which is 1. So c squared equals 3, c equals plus or minus radical 3, which is approximately plus or minus, let's see, radical 3. Oops. 1.73. So the foci was on the y-axis, so 0 minus radical 3, and 0 radical 3. So up 1.73 and down 1.73. Write an equation of the ellipse with the given characteristics and center at 0, 0. So we have some information where we know the vertex, the co-vertex, and the center. So with this one, first I would see which between vertex and co-vertex are bigger. Well, actually, the vertex, that's an indicator, right? The vertex is on the major axis, so this will be our A and this will be our B. So when we want to solve for x squared over a squared plus y squared over b squared equals 1, we can plug those values in and we get x squared over 7 squared plus y squared over, this would be our b squared, equals 1. We can solve those. So we have 49 plus y squared over 36, because that's negative 6 squared, equals 1. And there we have an ellipse centered at the origin. And finally, we're going to write an equation of the ellipse with the given characteristics and center at 0, 0. The vertex is at 0, 7, and a focus at 0, 2 radical 6. Center's at 0, 0. So now the vertex, this is the major axis, so we know this will be our A value. The focus, we have one of the foci here is at 0, 2 radical 6. So when graphing, we can put a vertex at 1, 2, 3, 4, 5, 6, 7, centered at 0, 0. And then I found 2 radical 6. No, I didn't. Let's see. 2 times square root of 6. 4.9 about. So that would be 1, 2, 3, 4.9. So there's one of our foci. So now when solving, this is our c. So when we do c squared equals a squared minus b squared, we can plug these values in, and we can find a b. So we get 2 radical 6 squared equals 7 squared minus b squared. So we can, because of exponents, do that to both. So this will be 4 square root of 6 squared, that'll be just times 6, equals 49 minus b squared. So 24, because 4 times 6 equals 49 minus b squared. Subtract 49 from both sides, we get negative 25 equals negative b squared. Divide by negative 1, we get 25 equals b squared. You could solve for b, but at this point we have enough information to write our equation. So since this is our a squared equals 49, because 7 squared is 49. And that is the major axis is under the y, so a squared is under the y-axis. X squared over b squared, which was 25, and it's always equal to 1. So there we go. That is an introduction to ellipses. Thanks for watching.